Hey everyone, today we're going to see how we can graph quadratic equations in standard form. But before we begin, let's take a look at what we've done so far. So, we first started with standard form on the left. F of x is equal to ax squared plus bx plus c. We know that a is equal to -1, b is equal to 4, c is equal to 5. We've factored this equation so that it looks like it's an intercept form, which is all the way on the left. We're going to get to that very soon. But let's take a look at our last lesson, vertex form. Notice how a is still -1. And I can rewrite this equation into standard form like this. Y is equal to -1 x minus 2 times x minus 2 plus 9. I'm going to always remember the order of operations. X times x, x squared. X times -2, -2x, -2x, positive 4, and that plus 9 comes to the end. I'm going to combine like terms. Always simplify your equations before continuing. That'll help the process and prevent you from making any type of mistakes. Now again, I'm going to try to remember the order of operations. -1 needs to be multiplied to every single term here. Let me just use a different color so we don't get confused. Get negative x squared. Negative times this negative. Positive 4x minus 4x plus 9. Now I can rewrite it one last time. Sorry. And we can see that we have the same equation in standard form, just like this. Now in intercept form, this is a little bit different. We have, excuse me, p is equal to -1 and q is equal to positive 5. We're going to get to what that really means in just a second. But again, I can also write this in standard form. Just going to use the FOIL method, or a double distribution. X times x, x squared. X times -5, -5x, plus x minus 5. Can't forget about this negative. X squared minus 4x minus 5. I will distribute this again. Negative x squared plus 4x plus 5. So, as you can see, these are different forms to represent the same equation. And it'll all be based on what information we're given in order to solve the problem. So, let's go over some definitions. So like I said, those numbers are represented P and Q, as you see. Now this is my intercept form. F of x is equal to a times x minus p times x minus q. Now, P and Q are my x-intercepts. Well, what that means is that they lie on the x-axis. So as you can see on the graph, we have 2 points that lie on the x-axis, resulting in a value of 0 for y. Now, I ask you, what is your understanding of the axis of symmetry? What do you know between these 2 points? Well, they're equidistant. So the distance between the axis of symmetry and this point has to be the same distance between the axis of symmetry and the other point. And that holds true for every single point on this graph. Now, if we're not given the axis of symmetry, we need to calculate it. In order to do that, we need to divide the total distance by 2. So we need to divide this whole distance by 2 so we can cut it in half to get my axis of symmetry. In order to do that, you see the equation here and here. This is how I'm going to calculate the axis of symmetry. Then I'm going to use that value to substitute to find into the function to find my vertex. Something also to note, that the intercepts are also called the roots, zeros, or solutions, depending on the problem. Just as the vertex form and standard form, when a is greater than 0, the graph will open up. And when a is less than 0, so all negative values, the graph will open down. So let's take a look at this example. Well, you should automatically see that p is equal to -1 and q is equal to 5. And my axis of symmetry is equal to 2. Now taking a look at this equation, I want to rewrite it in intercept form. One way of doing this is by factoring. We've learned different methods to factor. The easiest way is to simply factor out the negative so that I don't have to do the AC method, which is a little bit longer and has more steps. Now I want to find the factors of -5 that add to -4. And that happens to be -5 times 1. Perfect. Now this is exactly what I needed, right? This is now my P and Q. And hopefully you've caught on that this is different than my values down here. And the reason why is because we still haven't solved this equation. By solving, I mean I need to calculate the roots or the zeros. The zeros being I need to know what value of x I have to have for this function in order for y to be 0. And so using the zero product property, I'm going to set each factor equal to 0, like this, and then I'm going to solve -1, x is equal to -1, and x is equal to 5. And now hopefully you notice that these are now the same. So it is important to know, and I'll clarify in my next slide, that we take the opposite sign of what's inside the parentheses, because when we solve, you'll see that they change like that. So let's go over a few examples. So I'd like you to pause the video and try this on your own before I give you the answers. So pause it now. Great. Now let's take a look and see how you did. I'm going to use the zero product property again. Sorry. And then I'm going to get x is equal to -7, x is equal to 8. And so now you can say that p is equal to -7, q is equal to +8. And again, if you remember, you take the opposite signs because of what I just did. So I can basically skip the step and say p is equal to +23 and q is equal to +2. Again, just to clarify, the reason why is because there's a negative already in my equation. So if I'm substituting 23 for p, I'm going to take this number directly into my equation. And notice I have x minus 23 because there's already a negative in my equation. And so I need to substitute a positive 23 in order to maintain that negative. The same for this 2. Now taking a look here, p is equal to negative 2, q is equal to negative 6. Again, looking back at my intercept form equation, I have x minus my value p times x minus my value q. Using a different color, I'm going to substitute negative 2 and negative 6, and you should see x plus 2 times x plus 6 because of these two negatives. A negative times a negative is a positive. So once again, you must change the signs when they're inside the parentheses in order to identify the root solutions or the value for p and q, which mean all the same thing. So let's see how this translates to when I need to graph. So the easiest first step would be to identify the x-intercepts, in which case p is equal to 1, q is equal to negative 2, which means that my intercepts are 1, 0, and negative 2, 0. So I'm going to come over to my graph. Here is 1, 0, and here is 2, 0. Now my value of a is positive, so my graph is going to open up with my vertex at a minimum, with a minimum value. And I have to calculate my axis of symmetry. And if you hopefully you remember, it's x is equal to p plus q divided by 2, because we want to cut it in half into 2 equal parts. And so I'm going to substitute my value here. 1 plus negative 2 divided by 2 is going to get me, excuse me, negative 1 over 2. Great, that is my axis of symmetry. So negative a half is about here. But I don't know where my vertex is. And so now I need to substitute this value into the original equation. So I'm going to rewrite it up here. F of x is equal to x minus 1 times x plus 2. So using a different color, I need to substitute this negative 1/2. Negative 1/2 for every value of x. So negative 1/2 minus 1 is negative 1.5 times 1.5. 2 minus 1/2. So now I need to do negative 1.5 times 1.5. And I get 2.25, and it's negative because of this negative sign. So I am going to be just about there. And now I'm all set to graph. This is how you graph a quadratic equation in intercept form. Let's take a look at a few more examples. Here, I have the function f of x is equal to 2x squared minus 8. And I need to rewrite it in the quadratic function in intercept form first, because I need to know what P and Q are. So in order to do that, we have to recall the information that we know about factoring. And so I can factor the greatest common factor, which is 2. And I get 2 times x squared minus 4. And hopefully you notice that this is a difference of squares. And I can factor it once more, as so. And now I want to identify the x-intercepts, which are p is equal to negative 2. Again, we're taking the opposite sign here. And p is equal to 2, or q is equal to 2, because we're taking the opposite sign for when we use the zero product property and solve. So now I want to plot these 2 points. Negative 2, 0, and 2, 0. I need to then calculate the axis of symmetry. Again, x is equal to p plus q divided by 2, which is going to equal to 0. So my axis of symmetry, this in red, is right on the y-axis. Lastly, I need to find and plot the vertex. So I'm going to use my value of x, 0, and I'm going to substitute it into my original function. So for every value of x, I'm going to substitute a 0. So 2 times 0 squared is 0, minus 8 is negative 8. Now I know that I can plot my point at 0, negative 8. And I have enough points to draw a rough draft or a rough sketch of my quadratic equation. And that's it. Alright, let's take a look at one more example. Here I want you to graph y is equal to negative 2 times the quantity x minus 3 times x plus 4. So p is equal to 3, q is equal to negative 4, which means that my intercepts are at the point 3, just about there, and negative 4, right about there. Now I need to calculate the axis of symmetry. X is equal to p plus q divided by 2, which is 3 minus 4 divided by 2 equals to negative 1/2. So that is about here. That's not enough to graph a quadratic that has a shape of a parabola or a U-shaped graph. I need to find the vertex. So I'm going to use my original equation. Y is equal to negative 2 times x minus 3 times x plus 4. I'm going to substitute this value for x. So y is equal to negative 2 times negative 1/2 plus 3, minus 3 times negative 1/2 again plus 4. Simplifying this to negative 3/2 times positive 3/2. Negative 2 times negative 3.5 times negative 3.5 is 24.5. Now I chose this because a lot of times you notice that you don't have 25 lines. And so we have to adjust the scale. Notice how my x-axis I'm counting by ones. 1, 2, 3. 1, 2, 3, 4. However, that's not going to work on the y-axis because I need to go up to 24.5 or 25. So I'm going to count by 2's. This will be 2, 4, 6, 8, 10. So this is 25. Perfect. Now I'm going to graph my vertex right on the axis of symmetry. Just about there. So whenever you notice a graph that doesn't have enough lines, you can always adjust the scales. You can count by 2's, by 3's, by 4's, whatever makes the graph inside your window or in your Cartesian plane. So now all that's left is for me to roughly sketch my graph. As so. So again, these are my x-intercepts, the roots, the solutions, or zeros of my polynomial. In this case, it's a quadratic. And this is my vertex. And it is a maximum. Now I'd like you to try. Take the time to follow the steps and graph this equation. Great. So what you should have gotten is something very similar to this. The intercepts is -1 and 4. The graph opens up because a is less than 0, as you see here. It's a big negative. The axis of symmetry, you should have gotten x is equal to 1.5, with this being your vertex. Now, let's do a little review of what we've learned so far. Vertex form. I want you to write an equation in standard form whose graph satisfies the given conditions. In this case, for this example, all I have is the vertex, which is -3, 4. So if you remember the vertex for the vertex form is HK. That means that I'm going to substitute the values of H and K. Because this is a negative H, and I'm substituting a -3, that will result in a +3 and +4 for K. Now I'm going to distribute this. If you don't remember how I get to the next step, well, that is here. X plus 3 squared, x plus 3 times x plus 3, x squared plus 3x plus 3x plus 9, x squared plus 6x plus 9. Again, that's here. Now I'm going to add the 4 in, and this is my standard form equation, and I'm done. Now let's take a look at intercept form. I want you to do the same exact thing. Write a quadratic function in standard form whose graph passes through the points -9, 0, -2, 0, and -4, 0. Which 2 points do you think are the x-intercepts? If you said the first 2, you were right. So I'm going to use intercept form to write my equation. Again, a times the quantity x minus p times x minus q. Substituting those values again, minus -9 x minus -2. Negative times a negative is a positive. Negative times a negative is a positive. So I'm going to use the other given points to find the value of A. Notice how I was able to substitute P and Q, but I do not know what my value of A is yet. So I'm going to substitute the values X and Y here. As so. For each value of X, I substituted a -4, and Y, or f of X, is equal to 20. Simplifying, I get A is equal to -2. And now I need to substitute this value into my equation as so. That's how I got this. And now I'm going to distribute by using the FOIL method to get my final answer of -2x squared minus 22x minus 36. So I'd like you to try again one last time. Give it a shot. Perfect. If this is what you got, congratulations, you mastered it. If not, feel free, rewind my video and watch it again and see where you made a mistake. It's always important to identify your mistakes so that you know how to prevent that in the future. That is all for now. I hope you enjoyed and learned a lot. Take care. Bye.